By the end of this video, you should be able to know what the HTTP protocol is, the Golang standard implementation, how to work with query strings, how to work with the Gorilla Mux package, and then put it all together in a CRUD pattern. If this interests you, stick along. The backbone of the modern day internet is the TCP/IP protocol. When you visit a website, for example Wikipedia, these websites are served from a server, and you need a client, for example your computer, to be able to access these servers. The address can be broken down into the internet language as the protocol, the IP address, and the port. Now let's look at each of these elements separately. Computers are architected into multiple layers, and the topmost layer is the application layer, which has the applications which serves the data that the users want. This can be file servers, email servers, or print servers. The layer below is the TCP layer, which multiplexes traffic to different applications via dedicated ports. The IP address is the unique address of the machine on a network and is the way to locate the machine on the internet. The IP layer holds this address, and the layer below is the physical layer where the actual signals pass through, for example Wi-Fi or Ethernet. HTTP stands for the Hypertext Transfer Protocol, used to transfer hypertext between a client and a server. We don't use the term hypertext anymore, we say hypermedia, because it also includes videos and sounds. The HTTP protocol consists of a server, which has access to some data which a user wants, and a client sends a request to the server to manipulate this data, and the server sends a response. This whole process is mostly asynchronous. There are some exceptions with HTTP2 streaming, which we will ignore for now. A HTTP request or response consists of two parts. Headers contain metadata about the actual data used by the user, and the body consists of the user data. HTTP status codes are used to signal the status of HTTP requests. They are 3 digits and defined in RFCs, and they are split into 5 categories: informational, success, redirection, client errors, and finally server-side errors. Now I have a simple boilerplate Golang repository with the main.go file and the mod files. I also just have a simple main function. I'm going to head over to the Golang package repository and look for the HTTP package. This is the standard HTTP implementation from the standard packages, and I'm looking for this code snippet of the HTTP server. So I'm basically going to just take this HTTP server, which is a standard implementation, and we're going to modify it a little bit for our usage. There's a bunch of imports that's a part of the standard implementation. So I basically need a HTTP handler to handle this server. Before that, let's make a few adjustments. I'm going to define the address. You can also make this a constant. And I'm going to do a bunch of print lines just to make the output look a bit pretty. Now what I need is a handler implementation. And if I go back to the package, I can see that there's a few examples. Instead of directly hard-coding the handler, I'm actually going to look for something called a servmux. A servmux is just used to multiplex traffic between different routes. So I'm going to just take the default implementation of the servmux and use that in place of my handler. Now this is good enough to run. You already have a simple web server. It does not have any routes, but we will get to that in a minute. As you can see, it's running on port 8080. Just to make sure that this is correct, you can use the lsoff command on any Unix-based operating system to check if the correct port is bound. And as you can see, my main program is binding port 8080, which is what we intended. You can now use the curl command to send HTTP requests to an endpoint, and I'm going to use that to curl the localhost. Localhost is basically a local reference, which is a convenient reference to the default network on your local machine. And you can check that by using the nslookup command, and you see that it just points to your local address. Now let's add some basic routes to our HTTP server. There are two ways of doing it, which is either defining a custom function or just fill in the body of the standard function definition. So we're going to choose the latter. Use the handle func option, set the route as the root route, and we are going to just fill in the body of this function. So the W is the response and R is the request. We're just going to add a custom header. This can be any value. Usually there are some standard defined headers, but we're just going to define any random header now. And we are also going to write the response code. In this case, which is just OK, which is HTTP 200. And also a body, whatever value you want to write. When we run the server now and we curl this location, you get the header, the HTTP response code, and a body. You can also change whatever header you want to. In this case, I'm going to change the response code to 202 or status accepted. And as you can see, this is how simple it is to change the response code. Now let us look at some basic HTML and styling. The simplest way to do this is to hardcode a simple HTML document defined as a string, which contains a basic header and a paragraph. And I'm going to use this index page as the body of the HTTP response. And if I just run this code now and curl this location, you get the HTML response. And as you can see, the curl command has automatically interpreted the type as a text/HTML. Just to follow convention, we're going to do this ourselves also. Now, on the other hand, you can also set the status code to OK, which is the standard status code, and just check that everything works. Perfect. This actually makes more sense when you look at it from the browser, because the styling is meant to be interpreted by a browser. So as you can see, the first line is a heading and the second line is just a paragraph. You can also inject basic styles in this way. It's not recommended to add complicated styles, but for basic styles, this works pretty well. We're just going to center align these elements, and as you can see, you can do that directly here. Web servers work with JSON all the time. Let's add this to our project. In order to do this, I'm just going to paste a simple JSON formatted string called user info, and I'm going to add an extra route to our web server, the users route. We should also make sure that we add the content type as application JSON, and we were just going to use this user info as the body. Now I'm going to run my web server again, and first make sure that the default route still works. And now I can query the users route to check that I have a JSON string, JSON value, and also the headers are correct. You can also do this through a browser to go through the users route, and you will have the raw and also the interpreted JSON from the browser. It's a good idea to occasionally refactor your code to keep it maintainable. Let's do that now. I'm going to define a package folder in which there's a server folder, and I'm going to define a new file called server.go within a package server. So this package will be imported by our main package, and I'm going to define a structure which contains our server methods, and it's always a good idea to add good Go docs. I'm going to use this server and define the two routes that we had in our main function. So to do that, I'm just going to add the server as a receiver and define the handle index, and I will also add a handle route function. So if you're using Visual Studio Code, which is my IDE of preference, you can have this split view where I can view both files at the same time, because we need to do a bit of copy pasting from one to the other. So now I'm going to move the function definition of the handle, the basic route function, and then set it up in my handle index function, removing all the extra stuff. The index page is not defined, so I'm just going to copy it over from the original file. And I'm going to repeat the process for the handle users function. And once again, it's really important to have easy readable Go doc. So just replace the body to make sure that the body of the functions match. Now that we have our package ready, we need to import this package in our main folder. Now the problem is when I do something like server.new, this doesn't exist. So let me define a constructor to the server. A constructor is basically a function that's a standard function, which is used to define the server and to return methods to define the basic values, for example. In this case, my server has no variables, so it returns a basic server, but in case you had some variables that need to be defined, you can do that here. Now, VS Code automatically gets the right import because it has some IntelliSense to do that. It does that in combination with GoPLS. Now, what I'm going to do is just replace these routes and use the functions from the server package. And voila. So there's a small issue here, which is that there is a redefinition of variables. So I'm just going to use SRV for my server and S for the standard server. And voila, we're ready to go. I'm just going to make sure that the existing routes work before we move further. So as you can see, the base route and the user's route work. HTTP servers often employ the CRUD pattern for handling data. Data elements can be created, read, updated, or deleted. The first element of the CRUD pattern is the create method. So let's edit our code a bit to make this happen. So I'm just going to add some changes to the HTML file. This is completely optional, you can ignore this. And what I'm going to do is to start creating a user/create path. So users can use this create path to create new entities. And I'm going to clean up some stuff here. So before we go create our methods, let's first create the entities which are passed from and to the client and also store some data. So I'm just going to create a type which is our user info. I only have 2 fields here, but you can have as many fields as you want. This kind of simulates our data. And what I'm also going to do is create a separate type which is passed to and from the client. The difference is that one of them is interpreted as a JSON value and is used to unmarshal from JSON, and the other one, user info, is internal, which is stored internally. And I'm just going to use certain fields. So as you can see, in the user struct, I'm defining the name. And also I'm going to tag that variable as a JSON. So this tag is what is used in the JSON as the key for this field. And I'm going to repeat this for email and age and make sure that the tags match the field. And JSON supports strings, certain types of integers, float, etc. So I'm just going to use a simple int value for age here. And inside the server struct, I'm going to have a map which simulates sort of a database. Normally, you would just have a database which you initialize here and you will write to a database server. But just for the sake of convenience, we're just going to define this right here. So the data that is read from the clients would just be thrown into this map. Entities can be created either using a put or a post request. It's usually using post. So what I would do is look for the method field of the request body and switch on it and add cases for put and batch and post. Now we must also handle the default case. So in the case that the client sends a method that we don't know or that we don't want, we can use this convenient HTTP request, the status method not allowed, to tell the client that you're using the wrong method. And then we need to check that the content type is correct because we're expecting a JSON input which has the user fields. So you can check that using the headers, and you just do a direct get on the key of the header. Make sure that the key is in title case with hyphens. And if it's not application JSON, then we will return an error. And in this case, the HTTP response code would be a wrong media type. Voila. And now we have ascertained that it is an application JSON type. Now we need to unmarshal this JSON. And before that, there's a shortcut way of doing it in Go within the same if block. So it's a bit neater to do it this way. So now we need to unmarshal this JSON, or try to unmarshal this JSON value. So the JSON value is sent to the server by the client as part of the body, and the body is an IO read closer. So you need to read it out of the body. So you can use the IO util read all method to read it out. And the body errors have to be handled, obviously. So this error, if there's an issue with reading the body, it means that it's an issue internally. This is not anything to do with the client request. So you will have to handle this request separately. So the response type would be an internal server error. It's a 500, which means it's an internal error that the client cannot do anything about. With such errors, the operators have to fix what the issue is. And now let's try to unmarshal this body since it has been read out of the request body. We are going to simply use the standard JSON unmarshaller. In case your body has some custom elements, you can also set custom unmarshallers, but that's beyond the scope of this video. And in this case, we have an issue with unmarshalling, and in this case, it's most likely an error from the client. So we are going to say it's a bad request, which tells the client that the request was incorrect. And this is an error that has to be handled on the client side. So maybe there's a missing tag, or there's a missing comma in the JSON fields, etc. Those are the common errors in JSON. And once you arrive at this point, we assume that the JSON can be properly read. And one thing, you have to make sure to close the body after you read it. This is quite important for handling HTTP requests. And now, just to make our life easier, let's have a small print statement and print the name of the user that we are going to create. And at this point, you would actually write something to a database. Since we are simulating this, we're just going to add this value to our map. And we are going to just fill these values in our map so that this map contains the key, which is the username, and the value would be the information that we provided as the JSON input. And I'm just going to copy paste these values directly from the request that has been unmarshaled. And voila, so you have a simple create method. Now when you use this create command, either via post or put, so now back on our command line, let's see how this code works. So if you go to the user's create path without any input, you correctly get the method not allowed because it's just an empty request which says nothing. So let's first fix that by using just sending a random JSON value. So on curl, you use the -d option to pipe in a data, which is a JSON value, a JSON field, for example. We need to first set the correct contents type to application JSON, which is what our code is expecting. Now that is correct, but then the JSON is wrong. So you correctly get the status 400 request. So now let's type out the correct value. Make sure that we set the correct contents type first, application JSON. We also make sure to, of course, dial the correct endpoint, which is users create. And in the data field, which is using single quotes, I'm going to define a valid JSON with the fields name, the email, and the age. And make sure that all the keys are in quotes because JSON keys are strings. And also note that the age field is an integer, so it has no quotes. So this is an interesting case. You're getting a panic on the server side, and I wanted to leave this in the edit because this is a very common error that a lot of Go programmers face. It's a very common error that we face. So there is a panic which says there's an assignment to a nil entry. You see, this map, unlike slices, maps need to be created before they are being used. So you've used the make to create a map, and now if you run the same again, you see that the user has been created, and you get the correct HTTP response, which is a 200. Query strings can be used to specify values to run queries on. For example, you can perform some actions on users whose name is Bob, or users whose age is 21, or you can combine them in a joint query to run actions on users whose name is Bob and who's 21 years of age. So now let's add a method to get users that have been created. So I will add another method to this server and call it the read users method. Just copy paste some of the boilerplate for the HTTP request methods. Now this will get you values from the /users path, and as explained before, this will get a value from the query string. So we will once again just switch on the method and make sure that it is HTTP get and error for any other type of method. And we need to fetch the name from the query string as explained in the previous section. So we are going to do that by a convenient method that is part of the HTTP request body that is provided, the HTTP request field that is provided by Go. So you use the query method and do the get on the key, which is the name. And if this name exists, so what we can simply do is pass this name to the map and see if a value with this field, with this key exists. And if this key does not exist, it means that the user does not exist. And we just send a HTTP 404, which is not found. Otherwise, if the user does exist, then we need to marshal it as a JSON value. So we are going to first copy it from our internal type into the externally usable user type, because this has the JSON fields that is required to be marshaled, or the JSON tags rather. And then we're going to use the standard JSON marshal type and handle the error if necessary. We can just use the one from above, and in this case it failed to marshal, and this is an internal error that the user can't do much about. And we are going to set the header to application JSON because it's really important, because we're sending a JSON response. Right, so now that we have the read users method, we need to tell our Mux to use this method and also to create the /users path, which is what I'm going to do right now. Just use the handle func to create users and use the read users method here. And back onto our command line, let's see how this works. So to get a user, you don't have to specify a method. You can just do a direct get. And there's no query string defined. So to define a query string, we use the -g option with the data, and then we say the name equals Bob. So this is what is used in the query.get name, and the key is name, the value is Bob. So we don't have anything yet. So let's just run through the process of creating a user. You can just copy paste the command from the previous section. So I'm going to create the Bob first before I try to get. And now if I do a get on the same user Bob, I see that I get the Bob user and all his parameters. For complex queries, these query strings are quite cumbersome to use. A more elegant approach is to define a primary ID, which is part of the path directly, and put the rest of the queries in a body. So let's head over to the Golang package repository and look for the Gorilla Mux package. The Mux package is a much more robust and fully featured HTTP Mux as an alternative to the default serve Mux. So we are going to look at how this method is defined and replace our HTTP serve Mux with the Gorilla Mux and replace the necessary variables. And we are also going to just import this package by doing a go mod.id. Voila. We also need to make a few more changes in our read users path. So first of all, we make the query string as name, and we can change this here using the getParams method. So in the mux.vars, you just add the HTTP request, which will pass through all the parameters and get the params with the key that you've defined. So the key here is name. And if a name is defined after the user's path, it will be fetched there. Now, if I look, the user's Bob does not exist, which is expected. And I'm going to first create the user Bob, and then I'm going to do a fetch again. And now, as you can see, the name of the user is in the HTTP request query after the user's path, which is a much more convenient and efficient way of defining APIs than using query strings. We can reuse this read users method for patching by making a few small changes. First of all, I'm going to change the method to a generic users method instead of a get users or read users. And now I can add another type, another switch case for the patch type. You can add any such types here. So I'm going to reuse the same piece of code and just add a new type. And if the method is a patch, then we will make partial update of the fields of a defined user. Now, what I'm going to do is just copy paste some stuff that is necessary for both types, for all types, I guess. And we can also see what else is necessary. So you will need to also unmarshal, read the body, etc. This is already defined in the create method, so you can just copy paste this. And what you can also do now is to be able to update a user, you need to first get the user, if the user actually exists in your mock database. And if the user exists, then you see which fields need to be updated, and then you update those fields. Now, while I was doing this, I also realized that this part of getting the user, whether the user exists or not, is actually common to both the get method and the use method and the patch method. So I'm gonna copy paste this stuff to the top outside the switch statement. So the fetching of the parameters is the same for each of these methods. And if the user does not exist or is not been created, you can neither get nor patch it. So I'm gonna move this up to the top. And if the user exists, then I check the method and take the action necessary. So if it's a patch type, then I read the request, unmarshal the body of the request, check that this user actually exists at the top, and then now I can do partial updates of this user. So first I get the user of this name, and I'm putting some guards here for the age and the email. You don't have to do this, it's just an example. You can also allow users to empty these fields, and you can set certain values. Now, a way for you to partially conditionally update, you can define these fields as pointers, and you can check on nil, but we're not going to do that for now. Make it really simple. If the user value is set, you set the age. If the email is set, set the email. And we're also going to have a few print statements just to make our life easier when we are debugging the code. And I'm also going to add another print statement for the get path or the get branch, and name it as get user, so that when we run this code, it's easier for us to see what's going on. I think that looks good, and let's go ahead and see how to run this. So I'm going to run the code again. First of all, create the user, just copy paste the command from the previous time. And now if I do a get, that works as expected, since we haven't really changed that part of the code. And now I'm going to do a patch request with the same application JSON and enter a body where I'm going to just give one field, which is the age. As I haven't changed the age, you're just going to get the same value, 22. Now let's see how this works when I make a patch with a partial change. So I'm going to use the same patch command, but instead change the age to 21. It has been updated, as you can see on the left, and now when I do a get, I see that the age has been changed. Now you can repeat this with all the other fields of the user. Alright, and finally, let's complete the CRUD pattern by adding a delete method. It's as simple as adding another case for the HTTP delete method. And the user has been read at the top and the name has been ascertained. So we're just going to print the fact that we're going to delete a user. The name is already pre-filled at the top. Now what you need to do is use the built-in delete function to delete a key in a map. It takes a map and the key as arguments. So let's pass our user's map, and the key will be the name that you have read right now, and that's it. That's all you need to do a delete in this function, in this method. Now you can actually run this and see how it goes. So I'm going to first create the user from above, and I'm going to first get the user to see that the user exists. Now to delete, all you need to do is, it's very similar to get, except that you define the method as a delete, so it's -x delete. And the user Bob has been deleted. As you can see, it's been printed. And now when you read again, it's a 404 because the user is not found, it has been deleted.